Okay, so now we will see some DFA examples. We will try to construct some DFA and we will see how we can do this. So we will start with a suppose the question is number one. Suppose there is a language L belongs to W which in 0 1 star means W is a binary string such that W has, as I just told you, that even number of zeros and odd number of zeros. Sorry, even number of zeros and even number of 1. Okay, this is what just we were discussing. So what I can do, you see, uh, if we just take our very, at the very beginning, if we consider that what are the different cases possible about the number of zeros and number of 1. Both can be even, both can be odd. Number of 0 can be even and number of 1 can be odd, as well as number of 0 can be odd and number of 1 can be even. Right? Just a minute. So now that means uh, according to that means we can see that we must have 4 states. Right? State number 1 is saying that it can be even 0 and even odd. Sorry, even 1. S2 can be even 0 and odd 1. S3 can be odd 0 and even 1. S4 can be odd 0 and odd 1. Right? These are 4 state of mind possible. Anyway, so we don't consider S1, rather we will consider Q1, Q2, Q3 and Q4. Okay. Now, naturally, one of these states will be the initial state of mind. And what should be the initial state of mind? Obviously, this one. Because if we consider that we have a string something like 1 0 0 1 0, then this string you have to check. When you are about to start reading this string, somewhere your reader is somewhere here, you have not seen number of zeros, any number of zeros, you have not seen any number of 1. So number of 0 and number of 1 you have visited is both are even. So that's why this state should be the initial state. Fine. So if I just draw a Q1, I'm here. Fine. Now see, on getting a 1, you are actually what your state of mind will change. Your number of 0 that you have visited remains same. That is even number of 0. But since you have visited a 1, that's why now the number of 1 you have visited will become odd. right? So that means the state from Q1 where it will go for 1, it will go to a state for state of mind of even number of 0 and odd number of 1. That is Q2, this one, even number of 0 and odd number of 1, right? So let's draw this Q2 state, and I can say that on getting this 1, I can jump from Q1 to Q2, fine. And similarly, if you, instead of 1, if you are encounter 0, for example, your string is 0 1 0 0, something like this, suppose. So you are about to start here. Initially your state of mind is in Q1. Now when you will read this 0, your state of mind will change about the number of zeros you have encountered, because number of 1 you have not seen, so you are already seen number, even number of 1, but as you have visited the 0, it will become total odd number of zeros. So that means from Q1 on seeing 0, your state of mind will become odd number of zeros to an even number of 1, something like Q4. So that means I can write a Q4 over here, and on 0 I will jump here. So I have both direction done from Q1 state. Now consider state of Q2. Q2 means even 0 odd 1. So on, if you are in Q2 and if you get a 1, this odd 1 will become an even. Zero number is a number of 0 that will remain even, but number of 1 that is odd right now, that you are in thinking, your state of mind will become even. So on getting 1, if you are in this state, on getting 1, your state of mind will become even number of 0 as well as even number of 1, which is basically Q1. So basically on getting 1, you will go back to this state, right? Let's draw it, I mean, literally. This is for 1. And what about if I encounter 0 when I'm standing here? You see, when I'm standing here means my state of mind is even 0 odd 1. And if I get a 0 on, say, I mean standing over here, that means this even 0 will change to odd 0, right? That will become odd 0 odd 1, like S3. That means I will go to S3, that means Q3, rather Q3, on getting a symbol 0. So both sides from Q2 is also complete. Let's go for Q4 right now. You are in Q4 means your state of mind is odd 0 odd 1. And if you get a 0, that means it will become even 0 odd 1. Even 0 odd 1, like this. So that means if you are in Q4, you will go to Q2 because of a 0. But because of 1, it will become odd 0 and even 1, right? Because if you are in Q4 and if you get a 1, this odd 1 will convert to even 1. But your state of mind with about 0 will remain same. So you will be in odd 0 even 1. That means in Q3. So that means if you are in 1, you will be somewhere over here. So both side of Q4 is also complete. What about Q3? You are in odd 0, even 1. So odd 0, even 1. If I get a 0, odd 0 will become even 0. Right? So even 0, even 1 will happen. And even 0, even 1 means Q1. I'm sorry, I had a mistake, I think. Just a minute. Q3, odd 0, even 1. Mm, if you are in Q3, odd 0, like this one, odd 0, even 1, odd 0, odd 1, odd 0, odd 1 is Q4. On getting 1, yes, on getting 1 it will become odd 0, odd 1. That is correct. And Q2 is even 0, odd 1. I have a mistake or not? Let me just check it once. Even 0, even 1, even 0, odd 1, odd 0, even 1, odd 0, odd 1. Yes. Even 0, even 1. I got a 1. Even 0, odd 1. And I got a 0. Odd 0, odd 1. If I get a 0, even 0, yes, yes, correct. So now got it. Even 0, odd 1. No, sorry, just a minute. Even 0, even 1. Even 0, even 1. Then from here to even 0, odd 1. Then from here to if I get a 0, odd 0. Oh, yes. Now I had a mistake actually, I think. I had a mistake. That is, if you are in Q2, that means you are in even 0, odd 1, this state. Then, if you get a 0, this even 0 will get changed to odd 0. So from Q2 on 0, it will become odd 0 and odd 1, like this one, Q4. So I think uh, it should be, I have a mistake about this number of states. It should be Q3 and it should be Q4. Why I am saying this, you see that initial state of mind is this, that is even 0 and even 1. On getting a 1, your state of mind about the 1 from even it will change to odd. That means on getting 1, you will go to even 0 and odd 1. Even 0, odd 1, that is Q2. So on getting 1, you will go to Q2. Fine. Then you are in even 0, odd 1 state. And if you get a 0, this even 0 will change to odd 0. Odd 1 remains same. That means from Q2 you will go to a state of odd 0 and odd 1. Odd 0, odd 1 is Q4, not Q3. That's why I have written Q4. Similarly, in this side, Q1 to Q3, Q1 is even 0, even 1. If you get a 0, it will become odd 0, even 1, right? And odd 0, even 1 is Q3, not Q4. So I had a mistake on writing this particular state number. Anyway, so if you are in Q4, that means odd 0 and odd 1, and if you get a 0, it will become even 0, odd 1, and even 0 odd 1 is Q2, right? That means from Q4 we will have a path to Q2 because of a 0. So your state of mind, I mean your state diagram looks something like this. And among these, as I told you, that L should accept only those strings which contain even number of 0 and even number of 1. That means after reading some set of characters, if the finite state machine is in the state either Q2 or Q4 or Q3, the machine should not accept the string. Machine should accept the string only when the state where the machine will belong will be Q1, because Q1 represents even 0 even 1. So that means whatever is your initial state, that can act as your final state also. That can act as a final state also. Okay. Now you see the scenario can be entirely changed if the definition will change. For example, if I write a definition something like this, just an opposite definition of this language, if I want to accept it. For example, L, suppose W similarly belongs to 0 1 star, no doubt. Now here W, sorry, I'm writing such that W has not even zeros, even number of zeros, and even number of ones. What I have written, W has not even number of zeros and even number of ones. We are not expressing explicitly whether even number of 0 odd 1 or odd number of 0 even 1, that odd number of 0 odd 1. I am not expressing it, but I am saying that it is not even 0 even 1. So I am saying that this, if you are in this state, you are wrong. If you have a string, after reading the symbols of the string, if the finite state machine in this state Q1, then it is wrong. But if it is in Q2, then it is correct. If it is in Q3, then also it is correct. If it is in Q4, then also it should be correct. Right? So that means the philosophy of transition from one state to another state is not changing. Right? The philosophy of transition from one state to another state remains same like this. What will change? The final state will change. So if we just draw the the same diagram in a small portion somewhere over here. For example, I have a Q1, I have Q3, here it is Q2 and Q4. And this is basically my initial state, and for 1 I will go to this one, for 1 I can come back to this one, for 0, for 0. So this strategy of transition from one state to another state will not change, obviously, because this strategy is defined for any string, right? So this is for 0 and this is for 1, this is for 1 and this is for 1 again. So question is that what will change? the final state will change, because I'm saying that W has not even number of string, but I'm not specifying exactly which particular combination. So this should be correct, this can be also correct, this can be also correct. So that means if on reading some set of string, at the end when you reach, if you are in this Q2 state, then also final state should accept. If you are in Q4 state, then also it should accept. If you are in Q3 state, then also your final state machine should accept. That means your final state will be this one, as well as this one, as well as this one. Both of these three, all of these three, considering all of these three as a final state, is justified. So now I think you will understand the meaning of this one. Yes, the meaning of this particular statement. Rest. Meaning of this statement. This statement, if this statement isn't a set of final or accepting states. Now why it is set, I hope now you can understand from this example. It can be a set of I mean n number of states. This n can be 1, can be 2, can be 3, can be anything. So this is the example of a DFA, of designing a DFA, but here it doesn't end, because now we should consider what should be the transition function, right? So the transition function over here, first of all, how many transition function will be there? You see, I have 4 states, state number 1, 2, 3, 4. From each and every state, I have a possibility to change to one of these other states because of zeros or 1, 0 or 1. That mean the number of state here equal to 4, number of transition per state equal to 2. Why? Why? Because sigma contains 0 or 1. Since I considered this statement, this one, that for every symbol you must have some path. That means for both 0 and 1 you must have some path from all the states. So that means total number of transition will be what? Equal to 4 into 2, 8. Something like del of, if you are in Q0, if you get a 0, then what will happen? If you are in Q0, if you get, if you get a 1, then what will happen? And similar thing for other cases, like if you are in Q1, you are in 0, then what will happen? And if you are in Q1, if you get a 1, then what will happen? If you are in uh, Q2 on 0 something, Q2 on 1 something, similarly Q3 on 0 something, and as well as Q3 on 1 something. And what that you can understand easily from this example, that Q0 to 1 to Q2 or 0 to Q3. That means Q0 to 1 to Q2 and 0 to Q3, right? Similarly, Q from Q2 1 to Q2 to 1 is Q1 and 0 to Q4. Q1 and it is Q4. And from Q2, oh, I'm sorry, it is written Q1. Oh, okay, fine. Actually, I started from Q0 here, right? But here I have written Q1. That's why maybe you will be confused, but don't confuse it. You can consider this is as Q0, this is Q1, this is Q2, and this is Q3. Okay, this is I have considered in this next slide. So Q2 0 means from 0 means it will go to Q1, that means Q0 and Q0 and oh, that means I had a mistake. I'm sorry. Even I have mistake. I have done the mistake also. Should not be Q3 Q2. Let's write the names correctly, unless confusion will be created. So Q1, 2, sorry, 3, 4. So Q1 to 1, Q2, 0 means Q3. Q3, Q2. Yes. Then Q2 to 1 means Q1, 0 means Q4. Q4, Q1. Then from Q3, it is 0 means Q1, 1 means Q4. And here it is from Q4, 0 means Q2, 1 means Q3. So you can express in this way. Even you can express by a table also, like your present state, your symbol, and what will be your next state. Like you will obviously have 8 options. Like this. So you can easily write, if you are in Q0, sorry, Q1, and if you get 0, then you will go Q3 like this. If you are in Q1, you will be in Q1, like you will go to Q2. So the same information you can express in different form. Okay. So this is the way by which we can express the finite state machine either by the state diagram or by the transition function or by the transition table. That's all.